Water. It's one of the most determining factors when trying to figure out if life could or ever could evolve on a planet. There are many other factors that we look for when determining if a planet could support life, but we start with water because it's how life evolved on Earth. Now, I am not a scientist from NASA yet. I am far from discovering the first fossil on Mars, but what I do know is diatoms. A diatom is a golden brown piece of algae, and when you Google why diatoms are important, you will most likely read they convert CO2 into oxygen. Now, how do diatoms help me find life on Mars in my future career? I do research in a Paleolimnology research lab at Indiana State University. I work under the advisement of professors who are experts in their fields. My current project is located in Lakeview Desert, which is a lake located on the border between Michigan and Wisconsin. I not only started working in a research lab before 19, the project I got to be a part of is aimed at saving a species of wild rice from extinction. Lakeview Desert is not just any lake. It's full of wild rice, or it used to be. The wild rice population is currently declining, and we still don't know why. And that's where we come in. Beyond converting CO2 into oxygen, diatoms also do this brilliant thing. They die. Over time, as diatoms die, they are preserved by their silica exoskeletons they leave behind. We use these microfossils to understand how the environmental conditions change over time. Scientists in the past, and even still to this day, are able to correlate specific environmental conditions certain species of diatoms thrive in. The easiest way I came up with to describe this idea is looking at something as simple and off-topic as foxes. These images are all types of foxes. However, we know they all thrive better in different environments. The winter fox or the white fox in the image thrives in colder conditions. The tan or desert fox responds oppositely, thriving in dry and warm desert conditions. And lastly, the red fox we find in conditions kind of in the in-between. If the environment changed and the climate shifted from the in-between climate to a warm and dry desert climate, we would expect the desert fox to be more likely to survive and reproduce. If we found the skeletal remains of desert foxes, for example, it would lead us to conclude at a certain time period this area was hot and dry. Diatoms work the same. However, I'm looking at changes in environmental conditions that are more narrow and specific, like salinity, changes in the amount of phosphorus, and changes in flow of the aquatic system. Diatoms are such great environmental indicators. I could also see how the water level changes over time just by a certain species being present. By understanding the species conditions diatoms thrive in, we can record the abundances of each diatom species per centimeter of core, which gives us insight into how the environment changed and exactly when the change occurred. This means we have the ability to conclude if a pollutant was inserted into the system, if a wildfire occurred, and so on. This hopefully will lead us exactly to when the lake's conditions changed and became out of equilibrium, and of course, allow us to help restore the wild rice population. But how do we do this? The first part is just taking the samples. The U.S. Army Corps of Engineers went out and took a core for us and mailed it to our research lab. We then process our samples, which involves adding different chemicals, heating, decanting, centrifuging over and over again to isolate our diatoms and phytoliths. Really, anything involving the lab work and processing of samples, I work under the advisement of Dr. Yost, which is one of the best individuals I could be working with when it comes to phytoliths or studying wild rice. And I would not get to be a part of such an amazing experience if he had not given me the opportunity. After the lab work is done and all of our samples are processed, this is where we split. Dr. Yost does the phytolith section, and I work more closely with Dr. Stone, which specializes in diatom analysis and taxonomy, and he was crazy enough to let me be a part of his lab. I then began looking at a microscope for hours and hours over the course of months. This is where I begin to identify the diatoms present and how each species becomes more or less abundant over the course of our sediment core. In other words, I am able to see how the environment changes over time. Now, it's great I'm saving rice, but why would a future planetary geologist hop on this project? Paleolimnology is the study of lakes and lake sediment to reconstruct past environments to understand what it was like in the past. And when I think about trying to figure out if Mars is or was inhabitable, I do not know a better skill I could be learning. When we read about water being on Mars' surface, there's not large bodies of water flowing. There's instead geological features like alluvial fans, which is just one of many indicators of past water movement. And if I get to go to Mars and be a part of the American space program in my future, I believe a good place to begin looking for past life on another planet is going to involve analyzing cores, which will show us what really happened on our neighboring red planet. And by analyzing a sediment core like what I am doing now, if there was life discovered on Mars, I could look at changes found throughout the core and make the correlations to what environmental conditions Martian life thrived in and compare it to our own. It could help us understand if Mars was like our planet in the past and if it could ever return to being habitable. When I tell people my age, and sometimes even people older than me, they have a hard time understanding how a background in geology is important to space exploration. And I believe without astro and planetary geologists, we would not be able to understand how our planet and others came to be how they are today. And the first step to becoming a multi-planetary species or understanding even what's out there is going to be uncovering the past to see if habitability is even a possibility. I may just be an undergrad researching diatoms now, but the training and experience working on this project has to benefit me more than not researching anything at all. And the work I do even now contributes to understanding Earth a little bit more and gives me even a little more information to help me understand other planets in the future. Thank you.